Hi everyone, welcome to my YouTube channel. In this video, I am going to explain you one of the very important topic from mathematical method of physics, that is linear vector space. We are already familiar with scalars and vectors. Vectors are those which has both magnitude and direction. So what is vector space or linear vector space? So definition goes like this. A linear vector space V is a collection of elements called vectors. So linear vector space which consists of elements which are vectors and which satisfies very important properties. So the properties are like this. So there are two properties, the vectors belonging to linear vector space are scalar multiplication and vector addition. So this is the first property. For every two vectors x and y belonging to V, there exists another vector in V denoted by x plus y such that, so again it follows some of the rules, vector addition. So x and y are what? Vectors belonging to vector space V. So there exists another vector which is addition of these two, that is x plus y. So some rules it has to follow. First one, vector addition is commutative. So vectors, if we add two vectors, it is commutative law. That is x plus y is equal to y plus x, where x and y are what? Elements of which belongs to V, vector space V. So second rule, vector addition is associative. So vector addition is also associative. So we have to add one more element or the vector, that is z. X plus bracket of y plus z equal to x bracket of x plus y plus z. So it is associative law, that is x, y, z belonging to vector space V. So another rule, that is if we add null vector or zero vector to any of the element, we get same element or the vector. So there is an element 0 in vector space V called the null element or null vector such that x plus 0 is equal to x. If we add null vector, we will get again same vector. So fourth rule, for any element x belonging to vector space V, there is an element in V denoted by minus x such that it also follows inverse rule. So x, its inverse is minus x. If we add these two, we will get 0, that is null vector. So these all are what? The rules satisfying the vector addition. Okay. So another property is vector scalar multiplication. Okay. Second property, for any vector x and any number k, there exists another element denoted by kx. So as we are calling k scalar multiplication, k is what here? Scalar number, then x is vector. So k into x in vector space V. If there is a vector x and any number k, then there exists another element, that is k into x in the same vector space V. Scalar multiplication satisfies the following rules or properties. So first one, k into mx is equal to, we can write like this, km into x. For any two numbers k and m and any vector, so we can multiply scalars with vector. So we can take m and k as vectors here, scalars. So we are multiplying with vector x. So that is like associative law itself. K into m x is equal to km into x. But only scalars we can multiply. not the vectors. So second rule, one unit vector or 1 into x, one unit vector into any vector x is equal to what? Same vector we will get. For multiplication we have to multiply with 1 here, so we will get same element or same vector x. So third rule, k plus m into x. If we add two scalars and multiply with a vector, we can write like this, kx plus mx, distributive law we can say. Or else fourth rule, we can add two vectors and multiply with a scalar, that is kx plus ky. So these are the rules for scalar multiplication. So this is what the overall vector space we can call, or the set of numbers k and m etc. is said to be field over which the vector space is defined. So whatever k and m we have taken, they are scalars, whereas x, y, z, those are all what? Vectors. If the numbers are real, we have a real linear vector space. If the space will be called a complex linear vector space if the numbers are complex. So we have two fields, real field and complex field. Real field consists of real numbers or real linear vector space. Complex field consists of complex linear complex numbers or complex linear vector space we can call. So this is all about the definition of linear vector space. So I hope this video is helpful to understand the linear vector space, its definition and the properties involved in the linear vector space. Thank you for watching.